Picture this, a region of space so distant, so calm, and so ancient that nothing there is supposed to move in any meaningful way. No stellar winds, no collisions, no active galaxies, just the slow expansion of the universe itself. That was the assumption. Then James Webb changed it. While analyzing deep-field infrared data, astronomers noticed something subtle at first, a shift, a displacement, a structure that appeared slightly offset between observation windows. At first, it was dismissed as processing drift, then as alignment error. But when the same offset appeared again and again across independent instruments in different wavelengths, the mood changed. Because this wasn't noise, it was motion, and that alone was a problem. On cosmic scales, motion requires force, force requires mass, and mass leaves signatures. But whatever Webb detected was moving without behaving like any object we know. It was not accelerating like a star. It was not orbiting like a galaxy. It was not being ejected by anything visible. It was simply translating through deep space, slowly but unmistakably, and that should not be possible. The structure appeared as a faint gravitational distortion, revealed only by how it bent background light. No glow, no emission, no absorption lines, just an imprint on space-time itself. When scientists calculated how much mass would be needed to cause that distortion, the answer was staggering. There wasn't enough matter there, not even close. And yet, the distortion moved, over time, directionally, purposefully. That is when concern set in. Because gravity is not supposed to move independently. It is not an object, it is an effect, and effects do not travel on their own. As more data came in, the displacement became undeniable. Measured across months, the structure had shifted thousands of kilometers relative to distant galaxies. That might sound small, but at that distance, it was enormous. This was not cosmic drift. This was motion against the backdrop of the universe. And suddenly, a terrifying question emerged. If something with no detectable mass can move, what exactly is moving? And what else might be out there doing the same thing, unnoticed? Once motion was confirmed, every assumption had to be reconsidered. Astronomers mapped the trajectory, expecting it to curve, slow, or respond to nearby structures. It didn't. The path was smooth, linear, uninfluenced by surrounding galaxies or filaments of the cosmic web. That alone ruled out most known explanations. Dark matter clumps don't move like this. Rogue black holes would produce radiation signatures. Massive objects interacting with space would leave chaos in their wake. This left something far stranger. The motion appeared inertial, as if the structure was not being pushed or pulled, but simply continuing along a path set long ago, like a cosmic projectile launched billions of years in the past. That raised a chilling possibility. What if this object didn't originate here at all? Some researchers propose it could be a relic from an earlier epoch of the universe, carrying momentum from conditions that no longer exist. Others suggested it could be a topological defect in space-time itself, a leftover from phase transitions shortly after the Big Bang. In those early moments, the laws of physics were different. Space may have fractured, twisted, or crystallized in ways that later smoothed out, except not completely. If that's true, then what Webb is seeing isn't matter moving through space, it's space moving through space, and that idea is deeply unsettling. Because it means space-time itself can carry momentum, direction, and persistence, something we never thought possible. Even worse, the structure's motion appears stable. It isn't slowing down, it isn't dissipating. Over the observation window, its speed remained constant within error margins. That implies longevity, survival. Whatever set it in motion did so with incredible precision. And then came the discovery that escalated everything. Webb identified two more structures with similar motion characteristics. Different locations, different directions, same behavior. That ruled out coincidence. These were not isolated oddities. They were a population. Sparse, yes, rare, possibly, but real and moving, quietly, invisibly through the deepest regions of space. The immediate concern is impact. Not collision in the traditional sense, but interaction. Gravitational interaction does not require contact. If one of these moving structures passed through a galaxy, it could subtly alter stellar orbits, destabilize planetary systems, or trigger star formation in regions that should remain dormant, all without leaving a visible trace. Worse still, simulations suggest that because these objects are not made of matter, they could pass directly through stars, planets, even entire solar systems, influencing them gravitationally as they go. You would never see it coming. There would be no warning light in the sky, just long-term consequences unfolding silently. And then there is the timing. The detected structure is not moving randomly. Its trajectory aligns, loosely but uncomfortably, with large-scale cosmic flows, as if it is following the same deep gravitational gradients that shape galaxy clusters. That suggests awareness, or at least sensitivity to the universe's structure. And sensitivity implies interaction. Some physicists have begun asking whether these moving distortions could represent a new category of cosmic entity altogether. Not particles, not objects, but persistent space-time configurations capable of motion and interaction. If so, then the universe may not just contain matter and energy, but travelers made from geometry itself. And that raises an even darker question. Could such structures form again? If extreme conditions produce them once, could they be produced near powerful astrophysical events today? Near black holes, near neutron star mergers, near regions of intense space-time stress? And if they can move, could they move toward us? Right now, there is no evidence of immediate danger. The detected structures are far away. But distance in astronomy is deceptive. What matters is not where something is, but where it's going. And for the first time, James Webb has shown us something in deep space that is undeniably on a trajectory. This is why scientists are alarmed, not because something is attacking us, not because catastrophe is imminent, but because motion changes everything. A static mystery can be studied. A moving one introduces uncertainty, prediction, risk. If space-time itself can carry momentum, then our understanding of gravity is incomplete in a way that affects everything. Navigation, cosmology, even the ultimate fate of the universe. James Webb was designed to look back in time, not track moving anomalies. And yet it has become the first instrument to reveal that the deep universe is not as frozen as we believed. Something is moving out there, something invisible, something massive in effect but absent in form. Whether these structures are harmless relics or signs of a deeper cosmic mechanism, one thing is clear: the universe is not just expanding, it is shifting, rearranging, and possibly transporting things we do not yet understand. History has shown that the most dangerous discoveries are not those that threaten us directly, but those that reveal how wrong our assumptions were. Webb has done that before, and now it may have done it again. Because if space-time itself can move, then the universe is far more dynamic, far more alive, and far less predictable than we ever imagined. And this time, it isn't standing still.